Okay, so today we're doing something a little different. We're going to try and forget, just for a little while, everything we think we know about, like how reality works.
Sounds fun. I'm in.
Right, we're going deep on this idea of coherence and what's called infodensity.
InfoDensity. So is that like how much information is packed into a certain space?
Yeah, it's like the idea that like how information is organized and balanced, it's like fundamental to, well, everything.
Okay, I'm intrigued already.
Me too. And the really wild part is this might not just be like some tiny tweak to our current theories.
You're saying it could be like a whole new way of looking at the universe.
Exactly, like a paradigm shift. And it might actually give us some answers to, the really big questions.
Okay, yeah, like what? Give me an example.
Well, think about dark matter, dark energy,
Mm-hmm.
even just how electrons orbit an atom. All those things might make more sense when we look at them through this coherence lens.
I see, like a whole new perspective.
Yeah, and that's exactly what we're going to do today. We're going to take a look at 6 key areas where this coherence and infodensity framework really shakes things up.
6 areas. Okay, I'm ready. Lay it on me.
So we'll start with the very basics. Electron orbits.
Right. Electrons orbiting the nucleus of an atom. We usually think of them in those probability clouds, right? Never quite knowing exactly where they are.
Exactly. But what if those aren't actually clouds of probability, but like stable coherence zones?
Coherence zones. Okay, I got to hear more about this.
Well, imagine it's not about randomness, but more about like a specific region around the nucleus.
Where?
Where the information, the infodensity is balanced just right.
Like it's the sweet spot for the electron to exist.
Yeah, exactly. It's like a perfectly tuned instrument. The information is vibrating at just the right frequency to make that zone stable.
Okay, so instead of just zipping around randomly, the electrons are actually like held in these specific zones by the balance of information.
Right. And then, those quantum leaps that electrons do when they jump between energy levels.
Yeah, those always seemed kind of mysterious to me, just instantaneous jumps between levels.
Well, what if those aren't actually jumps?
They aren't.
What if they're more like phase transitions in the atom's coherence structure?
Phase transitions, like water turning to ice.
Yeah, something like that. The whole atom, its information structure, it reorganizes when the electron shifts to a new energy level.
I see. So a change in information density triggers this shift, this phase transition.
Exactly. And this is where things get really interesting because this idea, it might actually point to a deeper rule behind these preferred orbitals.
Like a deeper, more fundamental reason why those orbitals exist.
Yeah, it could even solve some of those big mysteries of quantum mechanics.
You're talking about wave function collapse, stuff like that.
Exactly that. Maybe all that seeming randomness at the quantum level is actually driven by these very specific, orderly principles of coherence.
So it's not just probability and chance, but there's an underlying order to it all.
Right. And, for our listeners, those who really want to understand the why behind things, that's a lot more satisfying than just saying, well, it's probability. Deal with it.
Totally. It's like there's actually a reason, a mechanism behind all of this apparent randomness.
All right, so let's scale things up a bit. Let's talk about the forces that govern the universe.
Okay, we've got the 4 fundamental forces: gravity, electromagnetism, strong and weak nuclear force. All different players on the cosmic stage, right?
Right, with their own rules and quirks. But what if they're not all separate? What if they're just different ways that this underlying coherence shows up?
Okay, hold on. I'm following, but different how?
Well, imagine it like this. What if forces are actually coherence gradients?
Coherence gradient, so like differences in the concentration or structure of this information field.
Exactly. It's like different currents in the same ocean, like how temperature gradients cause heat flow or pressure gradients cause wind.
So the differences in the coherence field create what we perceive as these different forces.
Yeah. And think about gravity, right? It's the weakest, but it reaches the farthest. What if that's because it's the most broadly distributed coherence gradient? Like the universe trying to achieve a large-scale information balance.
And the nuclear forces, the ones that hold atoms together, they're so strong, but only work at tiny distances.
What if those are like super intense, localized coherent zones? Like little storms of coherence happening inside the nucleus.
Huh. That's a cool way to visualize it. So you're saying all these seemingly distinct forces are actually just different expressions of the same underlying phenomenon.
Yeah. And it even changes how we think about that fine structure constant, alpha.
The one that determines the strength of electromagnetism, right?
Yeah, it's not just some random number.
It's telling us something about how charges interact, about the fundamental nature of electromagnetism.
And if it's not actually constant, if it varies in different environments, then that means the coherence field itself is dynamic and context dependent.
Wait, very. So the strength of electromagnetism could actually change depending on the environment.
That's what the theory proposes. It's like
Mhm.
the rules of the game can change slightly depending on the playing field.
So then unifying the forces wouldn't be about finding one equation for everything, but understanding the coherence thresholds where these different forces naturally emerge.
Exactly. It's about recognizing they're all different expressions of this single underlying reality.
Wow, that's a huge shift in thinking.
Yeah.
Okay, so what's next? Where else does this coherence thing pop up?
How about light? You know, the thing that lets us see the electromagnetic wave.
Right, traveling at the speed of light, a universal constant. We learned that in, like, day 1 of physics class.
But what if light is more than just an electromagnetic wave? What if it's also a coherence wave?
A coherence wave. So it's not just traveling through empty space, but through this field of coherence.
Exactly. And here's the real kicker. If light is a wave moving through a coherence field, then its speed might not be so constant after all.
Hold on, are you saying the speed of light could change?
The theory suggests that in areas of really high coherence, the speed of light could actually vary. It's like the field itself is changing the rules of the game.
But that would turn Einstein's theory of relativity on its head. I mean, the speed of light being constant is like one of the pillars of modern physics.
I know it's a radical idea, but it makes sense within this framework. And there's even more to it. Think about the different effects of light frequencies on us.
Oh yeah, blue light being bad for you, red light being beneficial, all that stuff. How does coherence tie into that?
Well, the idea is that blue light, with its higher frequency, carries a lot of coherence.
Okay, so lots of information packed into those tight waves.
Right. And while coherence is generally good, too much of it, especially in a system that already has its own coherence, can be disruptive.
Like throwing a wrench into the works. So blue light disrupts our own internal coherence.
That's the idea. But then red light, with its lower frequency, it's thought to be more in tune with our natural rhythms.
So it actually helps boost our own coherence.
Exactly. It's like a harmonious resonance.
Wow, so light's not just about what we see, but it's also about information and coherence. It's interacting with us on a much deeper level.
All right, let's zoom out even further now, out to the galaxies and the mystery of dark matter.
Dark matter, the invisible stuff that supposedly makes up most of the mass in galaxies. It's how we explain why galaxies rotate faster than they should based on the visible matter we can see.
Right, but what if dark matter isn't actually matter at all? What if it's a coherence effect?
A coherence effect, so not some mysterious particle, but something to do with this information field again.
Exactly. The idea is that the centers of galaxies, they're super dense with information.
Super dense, meaning?
Like a lot of information packed into a small space, creating these really strong coherence fields.
Okay, so these intense coherence fields around the galactic core, what do?
Well, they basically amplify the effects of gravity.
Amplify gravity. So
Uh-huh.
the gravity from the visible matter is somehow boosted by this coherence field.
Yeah. It's like the information itself is warping space-time more effectively.
And that explains why stars in the outer parts of the galaxy are zipping around faster than they should.
Exactly. It's not because of some unseen matter, but because of this coherence effect boosting the gravity of what we can see.
So instead of searching for dark matter, we should be looking for these coherence gradients in the halos of galaxies.
Precisely. It would be a huge shift in how we think about galaxy dynamics.
It would revolutionize astrophysics. And, speaking of revolutions, let's tackle the granddaddy of them all, the expanding universe.
And dark energy, that mysterious force that seems to be pushing everything apart.
Yeah, dark energy, it's like the universe is blowing up a giant balloon faster and faster.
But what if dark energy isn't a force at all? What if it's just increasing infodensity?
Increasing infodensity.
Yeah.
So the universe isn't just getting bigger, it's getting more complex, more information rich.
That's the idea. It's like the universe is constantly evolving, organizing itself, creating more information. And what we perceive as this accelerating expansion might just be this process of information restructuring.
So instead of some mysterious force acting on space, it's just the universe becoming more complex, more coherent.
Exactly. It's like a cosmic drive towards greater organization. And this framework actually makes a testable prediction.
What kind of prediction?
That if we map the expansion of the universe, not just by distance, but by how these coherence fields are evolving, we should see a direct correlation with the distribution of galaxies.
So the growth of information complexity would be driving the expansion patterns.
Right. And that brings us to our last stop, the ultimate cosmic enigma. Black holes.
Black holes, infinite density, singularity, the place where physics breaks down.
But what if black holes aren't actually singularities?
What else could they be?
The coherence framework suggests they might be coherence condensates.
Coherence condensates. I'm picturing something thick and gooey, is that right?
Not quite. The idea is that as matter collapses under its own gravity, it reaches a point where the InfoDensity gets too high. Like it hits a coherence limit.
Okay, so instead of collapsing into a singularity, what happens?
The information, it reorganizes itself into an extremely dense but finite state. It's like a super concentrated knot of information, a condensate.
So the event horizon, that point of no return, it's not a boundary around an infinitely small point, but around this coherence condensate.
Yeah, exactly. And this model actually suggests that we might be able to detect subtle fluctuations around the event horizon.
Fluctuations, like hints of this information processing happening within the condensate.
Right. It would be evidence that black holes aren't just featureless singularities, but have a complex structure.
So we've gone from the tiniest particles to the most massive objects in the universe. And it seems like coherence and information play a role at every level.
Yeah, it's amazing how this one idea, this coherence framework, can offer a new perspective on so many things.
And the best part is it's not just theoretical. This model actually makes testable predictions.
Right, like looking for those variations in the fine structure constant, studying the energy behavior of superconductors, even analyzing the cosmic microwave background radiation for patterns.
All those experiments could give us clues about the validity of this coherence framework.
So for our listeners out there, think about this. How does this idea of coherence change your understanding of the universe? Does it give you a new perspective on your place in it all?
It definitely makes you wonder, right? If the universe is fundamentally about information and coherence, what other connections are we missing? What else can we explain with this framework?
It's a pretty mind-blowing thought, and honestly, it makes me wonder about consciousness itself. Could it be that even our own minds, the way we experience the world, is somehow tied to this idea of coherence?
That's a deep thought. Maybe that's a deep dive for another time.
Absolutely. But for now, keep those questions in mind. Keep exploring, keep thinking, and maybe, just maybe, we'll start to see the universe in a whole new light.
A more coherent light.